Hey everyone, today we're going to be discussing AppArmor and HTTPS. My name is Austin Nuthavong, and this is for ISA 4220 System Security 2. So, a brief overview of what we're going to be discussing. We're going to look into AppArmor, which is a Linux kernel security module which allows administrators to limit program capabilities, and this was released in December 21st, 2018, and this is also written in C and C++. We're also going to go over HTTPS, which stands for Hypertext Transfer Protocol Secure, which uses a standard port of 443, and this secures communication over a computer network. The communication protocol is encrypted using the TLS or Transport Layer Security. We're also going to discuss Apache Tomcat, which is an open source software which provides a Java inclusive HTTP web server environment. And this was released in December 12, 2019. And this was written in Java. And lastly, we're going to be discussing Microsoft IIS, or Internet Information Services, and this is an extensible web server created by Microsoft for the use of the Windows NT family. AppArmor is a Debian-based alternative to SE Linux and allows the ability to restrict access to certain application scripts or programs to only do certain functions. SE Linux is prevalent in Red Hat, CentOS, and Fedora. Mandatory access control or Mac systems is a kernel enhancement to limit programs to a certain amount of resources, and AppArmor binds access control attributes to programs rather than to users. If you're having an issue with a script not being able to access a certain thing, it's a high possibility that AppArmor is actually blocking you from using it, and you actually need to go in and configure it. AppArmor is already pre-installed and enabled on Ubuntu Server 18.04 by default. AppArmor profiles can be in one of three modes, which is enforcement, complain, and unconfined. Profiles loaded in enforcement mode will end up in enforcement of the policy. So if a program tries to deviate in enforce mode and jump outside of what it is allowed to do, it will be denied. In complaint mode, if a program tries to jump outside of what it's allowed to do, it will allow it to happen, but it will also log it. And for unconfined, the program can do whatever it wants on the system, and it's not going to be logged or recorded. AppArmor separates itself from other Mac systems of Linux because it is path-based, which means it enables you to mix both enforcement and complaint mode profiles, as well as including files to ease the development process. And it also has a much lower barrier to entry than some of the other more popular Mac systems. Here we're going to review just some basic commands of the actual service within AppArmor. The first one we're going to talk about is AA status, which provides an accurate readout of what AppArmor is doing. If you don't get anything, or the AA status is not available, or the module is not loaded, AppArmor is a service, therefore you should start it by doing a system control and just checking the status to see if it's running. If it is stopped, you should enable the status and hit start if it is disabled on your system. Likewise, if you wanted to disable AppArmor, you can type system control disable AppArmor. AA log proof reads log entries and updates any profiles on your system. And in order to do this, you just need to type sudo AA log proof. It's a maintenance command for custom profiles. So similar to how you generate a profile, you should actually log it to see if any changes have been made to update that profile. And this is useful once you have already created a profile and when the program runs through an update which requires privileges, this command will automatically update your profile so AppArmor will keep functioning properly. And lastly, we have AppArmor utils. So installing this package will allow you to generate an application for profile, and just typing this is sudo apt install AppArmor -utils. So now we're going to talk about HTTP, or Hypertext Transfer Protocol. This is the protocol that is used for viewing web pages on the internet. It's a complex application layer protocol used between at least two different computers to transfer packets over a network, used in conjunction with TCP and IP protocols. This defines how messages are formatted and transmitted, as well as what actions web servers and browsers should take in response to different commands. So if you type in a web address such as google.com, you will notice that HTTP is automatically added in the beginning of your web address, which indicates that you're using HTTP to retrieve that web page. So your computer is sending that request to the website to receive those packets from that website to view its data. All of the information exchanged between your computer and that web server is being transferred over the public internet in clear text, which makes it more vulnerable to malicious hackers. If you input sensitive information such as your name, your address, your phone number, credit card information, and so on, that data has to go through the public internet. Criminal hackers can listen in as that data is being transferred and steal your data, which is why HTTPS was created. So this is HTTP with a security feature. HTTPS encrypts the data that is being retrieved by HTTP. It ensures that all the data being transferred over the internet between computers and servers are secure by using encryption algorithms to scramble the data that is being transferred, making it harder to read. So if you were to go into your browser and go to a website that requires you to input sensitive information, like your bank website, you will notice that HTTPS is automatically added in the beginning of your web address, which shows that you're using HTTPS to retrieve that web page. So in addition to having the S in HTTP, it shows that you are on a secure website and the information that is being sent will ensure that it is going to be protected. Also, a lot of web browsers will show a padlock in the address bar to indicate that secure HTTP is being used. So now your data is no longer being sent in clear text, rather it is encrypted and it is nearly impossible to read for any attackers that want to steal your information. HTTP uses one of two protocols. The first one is Secure Sockets Layer, and this protocol is used to ensure security on the internet. This establishes technology for an encrypted link between the server and the browser. Only the appropriate recipient can view the packet since it is encrypted, and this uses public key encryption to secure data. The second one is transport layer security, which is the latest industry standard cryptographic protocol, which is the successor to SSL. And this authenticates the server, the client, and encrypts data. All right, so here we're going to discuss how to set up HTTPS using Apache Tomcat on Ubuntu Server 18.04. First, we're going to need Java. You're going to need to install OpenJDK and type in the following command, which you should then generate a certificate where you should be able to identify your username, password, and port number. Then you're going to need to install Tomcat and download the latest binary release. Then create a systemd service file and go through server.xml and enter the connector block for HTTP and restart Tomcat. Then you're going to go into your web browser and type https semicolon / your username / port number, and then in order to access the web interface, you're just going to need to bypass the certificate warning. Then you will see Tomcat is working over HTTPS. Here we're going to configure HTTPS using IIS on Windows Server 2019. IIS includes its own certification request tool that you can use to send a certificate request to a certification authority. So this tool simplifies the process of obtaining a certificate. And if you were to use Apache, you must obtain the certificate manually. And in both Apache and IIS, you receive a certification file from the certificate authority, which you must then configure on the computer. So first you want to log on to the web server as an administrator. You want to go through the following steps, going through Start Settings, Control Panel, Administrative Tools, and Internet Service Manager. Here you can configure and manage certificates by using the Directory Service tab of the website or folder properties. Then you want to select the website which you want to configure HTTPS and go through Directory Security, require secure channel, require 128-bit encryption instead of 40-bit encryption, and ignore client services. This will allow users to connect without supplying their own certificate by ignoring the client certificates. But if you wanted to allow a user to supply their own certification, you would just accept client certifications. Next, you want to configure client mapping. By enabling client service mapping, then you want to edit the map client certification to users. By configuring this functionality, you can map client certifications to individual users in Active Directory. And you can use this function to automatically identify a user according to the certification they supplied when they accessed the website. Okay, so this concludes the video. I hope you guys found this informative. I want to thank you guys for watching, and I'll see you guys in the next one.